Habemus Higgs. One day after the conclave of cardinals in Rome determined, through mathematical means, the identity of a new pope, another conclave, this one comprised of physicists at the Alpine retreat of La Boule, Italy, made a mathematical determination of their own. For the physicists, the discussion was moved, one surmises, not so much by God as by the so-called God particle, the Higgs boson, the subatomic rock upon which our current understanding of the material universe is built. The consensus, based on the latest data from the Large Hadron Collider LHC near Geneva, Switzerland, the long hypothesized Higgs particle appears to be real. But any larger forces or entities operating behind the scenes remain as maddeningly hidden as ever. Today is an important day, said Pierre Savard, the theoretical physicist at the University of Toronto who works with ATLAS, one of two independent Higgs hunting experiments operating at the LHC. Now there's serious evidence that this is a Higgs boson. Professor Savard is careful to say because some interpretations of the data still allow for more than one type of Higgs boson. But if there is more than one, or if there is anything else unusual going on, then nature is uncannily good at keeping it a secret. The news further strengthens the case that something like the Higgs has turned up at the LHC, building on evidence for a new particle that was unveiled in July 2012. The latest data go a step further by showing the new particle has some of the key attributes of the Higgs as predicted by the Standard Model of particle physics, the ruling dogma of the discipline. But, to the chagrin of theorists, they say nothing more. It's actually kind of a surprise that everything looks so much like the Standard Model, said Sally Dawson, a particle physicist and senior scientist at Brookhaven National Laboratory on Long Island. The Standard Model is so simple, it doesn't tell us so many things. Theorists first proposed the Higgs boson over 4 decades ago to account for, among other things, why the other fundamental particles that make up ordinary matter have differing values of mass. As the Standard Model envisions it, mass is simply a reflection of how readily a particle interacts with Higgs bosons. Put in metaphorical terms, a pope walking across a crowded street, Peter Square is far more likely to attract attention, which will slow his progress, than an inconspicuous seminary in making the same trip. In other words, the Pope got mass. The new results are based on more than twice the data that were available last summer, the result of trillions upon trillions of particle collisions. Significantly, they pinned down to key numbers that describe the new particle known in the lingo as spin and parity and both match the Standard Model Higgs. But that does not satisfy theorists whose real goal is not simply confirming the Higgs but explaining why it is that Higgs. On that score, the new results have snatched away hopes that the LHC has glimpsed something that lies beyond the Standard Model. A slight but interesting excess energy that was showing up in one channel of the ATLAS detector was not evident in its counterpart, known as centimeters. That means the excess is probably nothing more than a statistical fluke. We want to see new phenomena, said Veronica Sands, the theoretical physicist at York University in Toronto. For the moment there is no such thing, and so we are getting impatient. The impatience stems from the fact that many aspects of the Standard Model point to the likelihood of a more fundamental theory operating at a deeper level. Such a theory would presumably offer a more complete and satisfying explanation of nature, and would manifest at higher energies than the LHC has so far been able to achieve. But if such a theory is within reach of the LHC, theorists will have to wait. The accelerator is now shut down for repairs and will not resume smashing protons together until 2015. By then it should be operating at double its current energy limit, though exactly what it will find, if anything, is a matter of intense debate. One point on which there is more general agreement: the latest result should clear the way for a Nobel Prize in Physics to be awarded for the Higgs boson, possibly as early as this year. I think it is well above Nobel quality, said Dan Green, a particle physicist and CMS team member based at the Fermi National Accelerator Laboratory near Chicago. The question is to who. Although the Higgs particle is associated in name with Peter Higgs, now an emeritus professor at the University of Edinburgh, he is only one of several physicists who can lay claim to proposing it in the 1960s. And thousands more are involved in confirming the particle at the LHC. Solving how to award the Nobel for the find may be a challenge beyond the powers of theoretical physics. Perhaps the Pope can help.